Hello, Jesus. How are you?
Hi, man. Nice to meet you. And yeah, many thanks for the invitation to your podcast. Really, really happy to be here with you.
Indeed. I think we can get straight to the point. But well, Jesús Manuel Muñoz Tejeda, co-founder of Persei Space. Can you tell us a bit about Persei?
Yeah, I mean, as you said, I'm a Jesús Muñoz. I'm a doctor in space propulsion from Imperial College London. And during the last years, I've been working with different space technologies around Europe and outside Europe as well. And my latest venture is Persei Space, who I co-founded in 2023 together with some professors from UC3N, Universidad Carlos III de Madrid, and other universities in Europe. And yeah, since then I'm very, very busy, occupied into making space a sustainable and circular environment and economy.
That's very interesting. We will talk about a bit about your background later. As you said, your latest venture is Persei. But so, what's the let's say what's the pitch of Persei Space? What problem are you trying to solve, and if possible, how?
Okay, you want me to do the whole pitch? No, I will. I will summarize. Okay, so for per se, basically, what we're trying to do is to solve one of the major problems that there are right now in the space sector, which is space debris. Space debris is a big problem, as we know, but it is also an opportunity. It's an opportunity to develop new technologies, an opportunity to delve into a new market, to develop something that is going to be useful for the next generations, and also to learn from our errors and the mistakes that we made in the past. So in Persei Space, we're leveraging disruptive technology, which is called electrodynamic tethers, and these tethers are conductive tapes, like the ones you use, for example, to measure the table that you have at home. It's an
Mhm.
aluminum tape that interacts with the space environment. And by space environment, I mean the magnetic field and the ionosphere in such a way that it creates a force that can allow satellites to deorbit, meaning to decrease the altitude they have in orbit until they are at a certain point in which they can deintegrate into the atmosphere, leaving no space debris behind. So space debris is a crisis, as we all know, and in Persei Space, we're trying to solve it using new space technologies based on the electrodynamic tethers.
So this is a novel idea, and it's very promising, of course. But does this mean that the spacecraft wouldn't need to carry extra fuel to the orbit, but just a component that can be deployed?
Yeah,
And
it's a very good question, and it's also one of the traits and the value differentiators or competitive advantages of the technology is that as we are using the space environment, we don't need propellant to work. That means that satellites that deploy the tether, the aluminum tape that I told you about, can actually generate this force in such a way that they don't need propellant to make the deorbiting happen. So we call them propellant-free technology or propellant-less technologies because they don't need propellant to work.
okay, some questions come to mind. Let's does the has this technology been validated or used in the past? And if so, why is it not popularized already, given the growing concern about space debris, which only gets worse or seems to get worse?
Yeah, it's a very, very, very good question. So tethers in space have been flown several times. NASA, for example, already validated the fact that you can use propellant-less technologies based on tethers for the orbiting and propulsions at the end of the 1990s. And the thing is that in order to commercialize this technology, different things need to happen. The first one is that you needed to have a market, and the deorbiting market is something that is being opened right now. It's a blue ocean because we came to the point in which we actually needed and we are forced to have solutions in order to deorbit satellites. It wasn't like before there was a problem, but as it wasn't a big concern, people were more focused on basically make things to fly in space, which was already a very big problem, right? Now we know how to fly things in space, how to make them reliable, how to make satellites robust enough. And now what we're trying to do is to have a circular economy in which we don't pollute what we use in space. So the first one was this one, the opening of the new market, and the second one has been the latest developments in this technology. So Persei Space also, although we were founded in 2023, we are a company that is leveraging the knowledge of two European Innovation Council projects. One of them started in 2019, it's called ETPAC, and the other one started in 2022 with the name of ETPAC F. So from 2018 to nowadays has been 6 years of continuous development, improvement in order to make something that is an investigation and research focused project, a product into the market. So the development of this technology takes years, millions of in development time, and now we are in the point where we have the market and we have the readiness of the products to the point where we can fly them to space and probably make products from it.
That's yeah. You mentioned a very good point, because when the space industry sort of started growing, the market and the economy, yeah, I guess everyone was only concerned about putting satellites to orbit, and then once they were reaching their end of life, it was cheaper to push them further away to the what's it called, the cemetery orbit, rather than deorbiting them. But now, of course, it's
Of
it's
course,
it's also an
we want to
environment that it's
do
growing.
exactly.
Pardon?
We want to do better and better. Like
Exactly.
the beginning was simply a validation, go there, make business, and now we have also this social mindset in which we need to be careful and mindful
Of
of
course.
what we do in
Of course.
space,
Of course. Of course.
because to the point that it is right now, it is been a problem. It's been a problem for everyone, because space debris is something that maybe people nowadays don't understand what can be the consequences if we don't act. But there is something called a snowball effect, which is that if you start launching things into space, not only you have probabilities of collisions, but if there is one collision, then the snowball effect is going to create more collisions in space. And there is something interesting, which is called the Kessler syndrome. And the Kessler syndrome, for the audience, is that nowadays we have a certain number of objects in space, right? Let's put a number. If we don't launch anymore, imagine that today all the launches stop, the number of objects in space is going to increase. And it is going to increase because of the collisions that are already happening in orbit. So the Kessler effect is the fact that the number of objects in space increases, even though we are not launching anymore, because of the collisions that can happen throughout the years. So this is a crisis, and this is something we need to have technologies and support from.
And that's why there's starting to be more and more regulation about space debris and how to deorbit and when to deorbit, and about the need to deorbit certain spacecraft, right, in orbit.
Exactly. For example, in America, the Federal Communications Commission, the FCC, set the orbit time from 25 years to 5 years. And this is a massive change because in the past, 25 years was kind of the same as saying there is no regulation. Because if you are on the directive of a company or if you are the CEO, you're not going to be 25 years to take accountability of what is happening to your satellites, right? But 5 years is already something that you can say, okay, we need to act because in 5 years something is going to happen, and if we don't act, then we are going to get fined. For example, in America, we got the first fine about like this deorbiting and pollutions as an exemplary on how strict this regulation comes into America. And in Europe, we don't have regulations yet, but we have something called the European Space Agency Zero Degrees Charter and the Zero Degrees Approach, which is the certain policies that are being created in Europe in order to set the same deorbiting time, which is 5 years, and also some other policies and recommendations on how to deorbit satellites. The idea is that in the future, we're going to have regulations in Europe as well. And this is what in the European Space Agency and in Persei Space, we're collaborating with the Zero Degrees Charter in order how to make this happen in such a way that first doesn't kill the industry. Because if you put too much regulation, then the industry stops, and this is something we don't want. And the second one is that to make it in a way that launchers, integrators, and clients are all happy with it. So this is what we are trying to do right now. In Europe, it's more complicated because there are different nations, and some laws need to be approved at a national level. For example, in the French law needs to approve these 5 years, the orbiting time, Spain, so on and so forth. But we are coming there, and we are trying to make more and more progress towards that.
And that's quite a point, because as you said, regulation, sometimes over regulation kills an industry, and perhaps Europe is unfortunately famous for that aspect, no, because perhaps we over regulate, or we tend to over regulate things a bit too much. But on this side, perhaps is that this space debris is an area where a bit more regulation could be more helpful indeed. And so, how are you? Let's say, I could imagine that in the past, eventually, that sort of hardware that you provide, which we can dive deep into in a minute, into how it is and how it works, could be, let's say, made a mandatory part on every spacecraft or so, or something like that, right?
Yeah, so the idea is that first, as you said, we need to develop technologies and regulations that help the industry, doesn't kill the industry, because we already know that the space sector is already something very, very complex. It's very complex. It's very difficult to make business out of because there are many startups and many ideas and many space lovers that want to get into space, but actually the number of clients is limited unless you go to massive operations like Earth observation, military spacecraft, or so on and so forth. Right? Typically, there are many partners, many intelligent people, and to make business in the space sector is very difficult, and that's why public funding is also very helpful. Like space, as you know, is an area, a sector that is massively publicly funded, and this is because we actually need the help from the public agencies in order to make this technology happen, right? So first, what you said, make it so that it doesn't kill the industry, and then make it in such a way that it can allow new satellites to the orbit. And we can do it in several ways. So if you want to deorbit, there are different solutions. For example, you can use our technology, tethers, that the main advantage, as I told you, is first that they are propellantless, they don't need propellant. And the second one is that they can be set into an autonomous system, meaning that if the spacecraft for some reason doesn't work in space after 5 years, which is something that happens most of the times because you've been working with the communication system, the power system, the propulsion system, right? If there is a failure, which happens, then it's not going to be able to deorbit by itself. On the other hand, if you have a subsystem like ours that is autonomous, then no matter what happens to the satellite, it can deorbit by itself. So new customers can use our solution either as the primary deorbiting solution or as a backup option in case they need to ensure how to deorbit. And
That's
I can
interesting.
make a very small point here, and is that autonomy in these spacecraft deorbiting devices is very important, not just for new satellites, in case the satellite fails, as I told you before, but also in order to eliminate space debris that is already in orbit. So imagine that there's a satellite that is dysfunctional and is orbiting around the Earth, that is not working. The only way to deorbit this satellite is that either you use one satellite yourself to deorbit it and put it to a lower orbit, or you can use the same satellite, but instead of grabbing the spacecraft and putting it down, you can attach one of our subsystems into this satellite. Then the mother spacecraft goes out, and then the space debris that has already the small subsystem integrated can be used in order to deorbit the satellite by itself,
And
which
that
is very
is
cool.
a much better idea than using a catcher satellite to actually deorbit like a piece of space debris or a dead spacecraft.
I
Because
think
then,
so too. Because also imagine the amount of space debris missions you can do with just one mother satellite. If you have 10 payloads of our autonomous subsystems, you can basically deorbit 10 dysfunctional spacecraft. If you just have one spacecraft with one robotic arm, then you need to go up, go down, and maybe if you go up, if you have enough propellant, then you can do the second one. And this brings me to a point which is very interesting, Jaime, and is that in our company, what we're trying to do now is like deorbiting satellites. This is the main goal, and this is what we're going to demonstrate in orbit in 2026. But we want to scale this company also to the propulsion sector and the propulsion free sector of in orbit servicing vehicles. Because as I told you, this technology creates a force, and this force can be used to deorbit satellites, right? And what you can do is that if instead of using the force to the orbit, you use the force to propel the spacecraft, so you reverse the current and the force orientation, then you can have a system that doesn't need propellant and a system that can put satellites up and down, basically with infinite specific impulse, meaning that it can be done as many times as you want. So for in-orbit servicing vehicles, this is also very interesting.
Wow, that opens sort of like a new world, because then you could be able to move in space, yeah, without propellant,
Basically, yeah, this is what
just
we
by
want to do.
managing the electric force, the electromagnetic force interaction between the tether and
And
the
the
magnet.
ionosphere, yeah. This is only limited to LEO orbits. We need
Of
to say
course.
that because we need to have enough density of the ionosphere to make it work. But if you see, think of an in-orbit servicing vehicle that has this type of propulsion technology, for example, active debris removal missions, it can go up, it can do one service to one satellite, it can go to another one, and then the lifetime of the satellite will be limited by other factors, not the propellant amount, which is a very big problem in this type of missions.
Indeed, because it mostly what, let's say, dictates the end of life of a mission, it's usually the amount of propellant that it can store.
Basically, if there is no
But
failure, the amount of propellant is one important factor for sure.
okay, that is amazing. I think you've opened many melons, so to say. But how do you the first question is, how do you make your subsystem, your tether, autonomous? How do you ensure that it can work, yeah, regardless of the state of the spacecraft?
So, for example, if you want to deorbit, you need a force, and the force can come from the tethers, from chemical propulsion, from
Mhm.
electric propulsion, so on and so forth. In chemical propulsion, which are the rockets that are launched from the Earth, then you need a very large amount of propellant in order to work. And because of the amount of propellant and because of the necessity to give the force in the right direction, which is also a big problem, then there has been no one who have been able to make an autonomous deorbit system based on chemical propulsion. There is one company that tried to do it, but unfortunately, what they did when they were in orbit is that instead of pushing the force down, so the spacecraft was deorbiting, they didn't do this calculation right, and the force was actually in the opposite direction, meaning in terms of the orbit, it came back. So
Oh,
yeah, this is a big problem. Like how you because how do you make sure that a force during several months is in the same direction all the time? This is something that it also needs a lot of ground control, very fine-tuned attitude system, and so on and so forth. So for chemical propulsion, no one has been able to do it. And for electric propulsion, this is not feasible. And it's not feasible because electric propulsion needs a very large amount of power in order to work. And what electric propulsion systems used to work is typically the solar panels of the whole satellite, because the
mhm.
solar panels of the satellite are large enough for the propulsion system in order to work. So in most cases, electric propulsion cannot be made into an autonomous deorbit device, but with tether systems, you can do it. You can do it first because the amount of propellant you need is zero. There is no propellant. And second one, because the amount of power that it needs to work is very modest in such a way that a subsystem of, for example, 12U that will be made for satellites up to 1,000 kilograms, then we'll be able to accommodate the amount of power needed for the deorbiting itself. And then in this box of 12U, we accommodate the power, the communication subsystem, the avionics, and so on and so forth.
Okay. That was one question. My next question was going to be how big the, let's say, the box, the deorbiting device is. But I think you already said it. 12U.
Yeah, so basically the in-orbit demonstration we're gonna do for the next year is gonna be a prototype of the product that we want to sell to customers starting from 2027, 2028. And this is gonna be this in-orbit demonstration, and this first subsystem is a 12U subsystem that has around 20 kilograms of weight, and it is going to be at an orbit of around 550 kilometers with the target deorbiting time of 3 months. So it's going to be much lower than the regulation that is 5 years. And the idea is that you can use this subsystem for a spacecraft that have a relatively large amount of mass, like from 200 to 1,000 kilograms. And if you want to make something that is more miniaturized for a spacecraft that are lower than 200 kilograms, in Persei Space, we're in a European Innovation Council project that is called ET Compact. Compact because it's more compact. And in that case, instead of having an autonomous system, we are developing a non-autonomous system that is going to be much more integrated within the satellite. And the idea is that it's going to be a 3U subsystem. So the
Okay.
possibilities of this technology are very large because you can have an autonomous system, a non-autonomous system. You can service satellites that have a lower mass of range, higher mass, and so on and so forth. So the scalability is one of the properties of the technology that we want to leverage as well.
Okay, okay, but I'm thinking that you would also need in your subsystem, you need a way of communicating either with the spacecraft to get let's say to receive the order to deploy the tether and the orbit and start the deorbiting procedure, or with the ground in case the spacecraft failed and there's no communication with the spacecraft. So
This is
you would
something
need,
that
let's say,
can
a
be discussed.
computer.
Yeah, this is something that can be discussed with the customer, but the current idea is that we communicate with the ground directly because we
Okay.
don't want to be dependent on the satellite communication systems for it to make the decision to deploy the tether or not. And then what we have is our antennas integrated into the subsystem that communicate directly with the ground. So this is very interesting because, for example, in the in-orbit demonstration, as we are autonomous, what we are going to do is to deorbit ourselves, basically. So we launch
Mhm.
the subsystem, and as we don't depend of the modern spacecraft, instead of putting, I don't know, 200 kilograms of mass that we don't need anyway, we are going to deorbit ourselves to be able to test the communication systems, the deployment, the power
Okay.
subsystem, etc.
That's very clever. That's a way of testing the whole of your offering. That's
Correct.
that's very good. Okay, so I think it's we've talked a bit about per se, and I still want to talk a bit more. But why don't we talk about a bit about you, about yourself, and about your past experience? Because well, you
Sure.
you you started a research project, if I'm not wrong, called DCH Dynamics, which perhaps is was the, let's say, where all your entrepreneurial spirit started. I don't know, but can you tell us a bit about that?
Yeah, very good point. So DCH Dynamics was a research group that I founded in 2000. Well, it's been many years ago, maybe 2019, I believe.
Wow.
And the idea is that we wanted to develop a new attitude control system for a small spacecraft that can leverage another natural phenomenon, which is called the Tassenevekov effect. The Dasanelokov effect, maybe people can understand better with a video, but the Dasanelokov effect is also called the tennis racket theorem, and is that an object with a certain inertial properties that is spinning, specifically around the intermediate axis of inertia, can leverage a 180 degrees flip, basically flip it like this, something that is periodic. And this is something that we wanted to use as an attitude control system for a spacecraft that doesn't need any type of energy to work, because as this flip happens naturally because of how the rigid body physics works, then we could leverage this for different attitude systems for a spacecraft. So we had this idea in mind, and I was thinking about it because I actually learned about this idea from a YouTube video. So I was watching the YouTube video about this effect, and I said, "Oh, this will be so cool to have it in the spacecraft, right?" And we started, from an idea to a YouTube video to me contacting my friends, people I knew were very good in working in a team, to demonstrating this technology in microgravity conditions in the European Space Agency program Flyer thesis. And we all have also patented the technology. We have written papers, conferences, posters, everything about this. So I'm very, very happy about what we did because we demonstrated for the first time that this Dasanevekov effect is something that can be controlled, meaning that you can stop and activate and deactivate this effect if you change the inertia of the system. And this is something we demonstrated for the first time. So it's one of the things I'm more proud of.
That's amazing, and it sounds, at least to me, a lot more complicated than what you're currently doing with the electromagnetic tethers. But what ended up happening with DCH?
So what we did first was to have we were in one international project that was called Nanostar, and Nanostar was a competition between different research groups in order to make this technology happen, and we were the winners of the Nanostar project. Then we came to ESA Flyer thesis, and with Flyer thesis we demonstrated this technology in zero gravity, and we were also very very successful because we demonstrated for the first time that this is something that could happen. And then from that point onwards, we needed to be very careful about the protection of the technology. So we worked on the patenting of the system, and the system has already been patented. And now that it's been patented, what we do, or what I do with my colleagues in the free time, is to write the scientific papers about the experimental campaign and what we got from it. So I think at the beginning of this year, we published the first paper about this effect, about how it works, and from a computational point of view, how you can control this effect. And the new one is going to be how we made this happen into reality. And but this is something I want to keep just for research purposes, not as an entrepreneurial path. Although they taught me a lot about team management, social skills, about pressuring under high tight deadlines, and so on and so forth. I learned a lot about how to build a team and how to make sort of a startup or a business model. But now I want to focus on Persei Space, because I think space debris is a major problem that we need to address, and we need very enthusiastic people about the social and circular economy in order to make it happen.
That's that's incredible, because of course, yeah, where you are right now, of course, is thanks to what you've done in the past. So I can imagine the amount of learnings that you've developed or derived from starting this research project, and managing to fly and validate that technology. But you also mentioned that you want to leave it as a sort of more as a research focus, let's say, project. And that leads me back to your experience and your education. You're an aerospace engineer, and you also did your PhD on
On
electric
water
propulsion,
and
if I'm
space
not wrong.
propulsion. Yeah.
Indeed.
So
So
my PhD is also one of the projects I'm more proud of, because when I started my PhD, my background is that I always wanted to do a PhD. That's how it was. And I was in Switzerland, and I was at CERN, the particle accelerator, and I was working there for 1 year and 3 months, I believe. And then I moved to the Swiss Space Agency, that is called Swiss Space Center. Now it's called Space Innovation. And I was working there, and I was having basically what many people would call a perfect life. I was having a very good salary. Switzerland is beautiful, the best country I've ever been in, surrounded by mountains. The weather is much better than in London, so I couldn't complain about it. And when I was there, I had always in mind the thought about doing a PhD, right? And although I was being offered some ideas on how to do a PhD, I wanted to do it in something that for me was something meaningful, not just about the institution or who you're working with, but also about the topic of research. And when I learned that Imperial College London was working on water propulsion, on how to eliminate the carbon footprint of propellants for satellites by transitioning to traditional propellants to water, and then I said, "Oh, I want to be part of this 100%." Right. So I applied for several scholarships to give me the funding, because we didn't have funds in order for me to be on the group, and I didn't get any of the scholarships. So I was rejected in all of them. They are very competitive. Maybe I wasn't good enough at the time. And what I said is like, okay, I wanted to do it anyway. And what I did was that I applied for a loan. And the first year of my PhD, I was covering everything with my expenses. So all
wow.
the money I saved in Switzerland is the money I used to cover my first year of my PhD at Imperial. And then, as I wanted to finish it and I wanted to make it happen, what I did was to apply to the European Space Agency. So the European Space Agency will contract me to do my PhD, because I knew this is something that would be interested. And then after some months of making the proposal, meetings, and a lot of stress, after 1 year, I was contracted by the European Space Agency to make this research, and everything turned out to be perfect, because I also had access to the ESA facilities in STEC in order to make all the experimental campaigns. And what we did in one of them was to demonstrate for the first time that you can use a water electrolysis engine of the type Hall effect thruster, and make it real in laboratory conditions. So use some water, a water electrolyzer that separates water into oxygen and hydrogen, put it into the engine, the Hall effect thruster, fire it, measure the thrust, and make sure that this is something that works. And this was the first time that it was tested end to end, that this is something working and something suitable and feasible, because at the beginning of the project, we didn't know if this was going to work. Especially when you electrolyze water, there is a ratio about how much oxygen and how much hydrogen you get. And you don't know if this ratio is going to be good or not for the engine. And it turned out to be good, and yeah, one of the proudest moments of my life for sure.
Wow. Well, okay, okay, because then, so this would be let's say if this worked and was implemented on a spacecraft, you would have your propellant tank, which would just be water, holding
Water,
water,
yeah. Hmm.
and then you do all the electrolysis process. You
Hmm.
separate water into hydrogen and oxygen. You
Hmm.
feed it into the thruster,
Hmm.
and that's it. And off you
And you
go.
have propulsion. And one of the cool ideas is that water cannot only be used for the electric propulsion system, but also for the chemical propulsion system. So you can have a chemical rocket functioning with water, an electric propulsion system working with water. You can use water for the thermal cooling. You can use water for the life support system of astronauts, because you know that manned space missions is something that is going to be more and more common in the next
Mhm.
years. So you can use it for the astronauts, for thermal cooling, inertia distribution. Is something that we call it multifunctional spacecraft architecture. This is how I call it, and this is my vision of how you could share a specific subsystem or resource like the water into different subsystems and make the most out of it. And this is my idea on how we can make a spacecraft better and better.
Well, that also links to Persei, right? You now are focusing on deorbiting, but eventually, further down the line, you want to also use it as a propulsion system, right?
Exactly, as a
To
propellant-less
to
propulsion system for spacecraft and in-orbit servicing vehicles. Yeah. This is the
exactly.
idea I had in my mind.
And but how does water work as a chemical propulsion?
So
Would it be
in
just by throwing like spilling out vapor or?
so the idea is that you need a water electrolyzer in any of the two cases, for electric propulsion or for chemical propulsion. And then in electric propulsion, you have the thruster itself, which is the Hall effect thruster that is uses oxygen, and then you have the cathode. That the cathode is basically a neutralizing gun that throws electrons in order to neutralize the beam. And then you have the combination of oxygen and hydrogen through the Hall effect thruster and the cathode. For the a chemical propulsion system, you need two components. You need a neutralizer, and then you need a base and an oxidizer. The oxidizer is oxygen, and then you have hydrogen. And if you mix them at a specific ratio, like the stoichiometric ratio, for example, basically you have explosion, because this is how water works. And not only for a spacecraft, but also for launchers. Some initiatives were done, for example, in a Ariane group, in order to make the rockets be launched with water instead of other propellants. So basically, as an experiment that you can do at home, if you are in the right vacuum conditions, so you don't have air, I let you figure out how you do that. Then you can use water, separate it into oxygen and hydrogen, and if you mix them, you have basically a bomb or an engine.
Exactly, depending on the use case, right? You
Exactly,
can.
depending on the use case.
Wow, that's amazing. That's amazing. So I see. You sort of have like a first of an ability to do things that not many people have done ever. Like water
Mhm.
propulsion, the effect.
The
I don't know
distant
how to
level.
pronounce the effect.
Yeah.
The
That's a Nevikov. It's
flipping
a very
effect.
difficult, yeah.
Exactly, and then deorbiting using tethers. So I think there's sort of like a common theme in your like in your experience and in who you are. Like you really like challenges and you really like doing things that have not been done and then doing them.
Yeah.
So that's amazing. How do you like? Yeah, how? I
How,
would ask how.
I
How do
mean,
you do
it's
that?
it's a very good question. Like, in my case, like my philosophy of life, also, I've been out of my home country many years, and I've changed countries 5 times. And
Wow.
sometimes you need to start from scratch, basically, with no friends, no partner, no house, no safe zone. And this also makes me think about what I want to do in life and how I want to live my life, because life is a treasure, and it's something that we need to be careful of, because we don't know how much it's going to last. And in my case, what I wanted to do is to help the community to do things that weren't being done before. Not because it's cool to do it, but because I think it's going to be useful for the next generations and to make your stepping stone into what you've done as an individual for the world. You know, so when I see an opportunity to do something that can be useful, and this is something that can be challenging enough but doable in such a way that I can be able to make it, then I go straight to it. And as I always say, as I don't have time to think about things that much, then I go straight to it anyway. Because if I will have the time to think about where on earth I'm getting into, then I will probably say no to it. But as I don't have this time, then I just go for it and say, okay, let's go.
Yeah, sometimes it's better just not to think too much, perhaps, no?
Yeah,
To
not to
to
think too
then
much, and also not to be afraid of taking risk. You know, like for example, here we are talking about the different projects and the success of the projects I've done. But for example, like all the struggles, all the things that didn't go as planned, or the things that needed to be done in order to make it happen, is something that people don't see, and they think, okay, it's going to be a straight flower path, and this is not the case in most of the cases, right? For example, the first year that I had to be a self-funded student with my own funds and so on and so forth, it was really struggling, you know, because you change country, you've changed job, you go to something that you don't know if it's going to work because it's a research project, then you don't have the funds, and it's very, very complicated, you know. But if you don't take the risk, you don't have the possibility to actually be proud of yourself when you actually make it, right? And I think life rewards people that take the risk in order to do something. And if it doesn't go as planned, so be it. Like life is very short. You can try again. You learn from your mistakes, and this is actually how you should live your life. Because if you don't take the risks now, when are you gonna make it? Like there is only one life
that's
to live.
exactly, that's such a good point to not forget that time is limited, and if if we don't take action now, we might regret it in the future, and that
Exactly.
oof, that is very risky. That's the real risk, I would say. I would say.
Exactly. It,
Yeah. Sorry.
No, you said a very good phrase that the real risk is not to take the risk right now because you might regret it in the future. And I think it's a very powerful phrase that you said.
Indeed, no, I see you're taking good note of it.
Yeah.
I also see in the background you have like a shirt hung
Oh,
up on
yeah.
the wall, and
This
that
is
seems to be space related.
it's also, yeah, this is my room. I'm working from home today, and this is a suit that resembles the one I flew during the zero gravity flight, and is merged with all the different stuff from the memories of me working in the space sector for many years. So, for example, every time I go to a space agency like NASA Jet Propulsion Laboratory, the European Space Agency, or CERN, the European Organization for Nuclear Research, I always try to get a souvenir from it, like
Okay.
something of a mission I've been working on, or something that the science is being pushed forward. And then I merge all together into this incredible spacesuit that also brings me some inspiration when I'm lost in my thoughts.
Okay, so it's like a living shirt, right?
Yeah, it's a
You
living
keep
painting.
adding. Okay, you keep adding things as you work on.
Exactly.
Then then I would recommend you start getting something else, because it probably won't fit.
Yeah, I should take the trousers as well, so I have the full
Exactly.
scale one.
Exactly, that'd be good. Because how was it flying on zero gravity? So you went on the zero gravity flight, the
Hmm.
parabolic flight, right, to test the attitude control, and how was that experience of flying on zero gravity?
It's actually very incredible because what the space, I mean, first of all, what you do is that you fly into a spacecraft or an aircraft that is the same as you will be flying, for example, from Spain to France. The difference is that this spacecraft, in the interior part of it, doesn't have any seats. There are only like two or three rows at the very end of it, but the rest of it is empty space. And this in empty space is where you put all the projects that you want to test in zero gravity. So once the spacecraft is already set up, what you do is that it goes into parabolic motion, and in this parabolic motion is where you get zero gravity. And it goes into three phases. The first one is that it starts climbing up, and then instead of having 1g, which is the gravity level that we have right now, we have approximately 2 times amount of gravity, so 1.8, meaning that you weigh 1.8 times the amount of you will be weighting here, which is also an interesting experience to test. Then you turn from being to 1.8 g to be in approximately zero gravity, so from almost 2 times your weight to zero gravity, and then you start going into 1.8 g again. So this is very harsh for the body and for someone that hasn't been experienced with these flights before. And this is why sometimes these spacecraft or these parabolic campaigns, as we call it, they are called the vomit comet, because people don't feel very well after all these parabolic flights and maneuvers that the very skilled pilot needs to be done in order to make it. And for me, it was very interesting the two phases, the 1.8G phase and the microgravity phase. The first one is because when you're in 1.8G, you can think about how much things weight that you don't realize in your normal life. For example, I was putting my jaw down, and when I was trying to pull it up, I was feeling the extra weight, which was something very awesome. And I
That's
had my,
amazing.
it's just that's amazing. And I had my phone with me, and I was feeling the weight of my phone, and as it was increasing the gravity, and you could think that the phone was actually almost twice the weight. So this is something that was also very interesting to check. And then when you go into zero gravity, the most similar experience is that if you go to a roller coaster, or if you go, for example, into your car, and then there is a bump or something that, or a tunnel, and you need to go down, and you feel something in your stomach, like this feeling
Yeah.
that, oh, something is happening, then this
Yeah.
is the feeling that you feel in zero gravity for the first 2 seconds. So this feeling of something in your stomach that it says, oh wow, something is happening, then you feel nothing, complete peace, complete calm, everything turns out to be floating, you feel perfect, then you start to feel it again, and then you go to the next parabola. So amazing.
Wow, wow. So okay, so the like that feeling on your stomach that you talk about, I felt it in the car quite a few times. It's only like sort of like the transition from gravity to zero gravity is that feeling, right?
Exactly, exactly. Because what's
Okay,
happening is that if you do this kind of stuff, the gravity that you perceive is different. So in zero gravity, this is what happens: that you from changing to 1.8 to zero g, you feel this stuff into your stomach that is like, oh wow, down we are traveling into zero gravity. This is amazing. And then it's like the one you have in the car, basically. Super
wow,
good.
that's amazing. I think it's a dream to many to be able to experience zero gravity. I guess
You can
that's
actually
why.
make it if you have money enough. There is one company
Actually,
that is called, I think, is Zero Gravity, and I think they are providing zero G flights for around 11,000 euros. So if you want to experience the stuff for yourself, you can actually make it. But I would recommend doing that with a project and an experiment, so actually doing science at the same time.
indeed, of course. And if not, you can always call Blue Origin and
Blue
or any
Origin, and
other
you go to one of
space
them.
tourism companies and just pay to fly. But no, that's amazing. That's amazing. You did it the clever way. You built a project which you could validate. You learned, and
You,
and
you
then you
have
got to
experience on top of
experience.
that. And one of
Exactly,
the things
exactly.
that happen in zero gravity is that you don't realize how much we rely on gravity nowadays. But when you are in zero gravity, for example, I have like a pen and I have one notepad, and everything was flying. So you need to, for example, take notes when you are in zero gravity, control your computer, control everything, and you can think about how difficult it is to control something that is free floating, that is spinning, that is doing the Senebekov effect, that you need to stop it, or you need to command the computer to change the inertia to control the inertia of the system to stop the effect at the right time, while you're also floating, while for example, your mouse is also floating, so you don't have the possibility of doing that. So it's an experience that you have to live for sure.
That's that's the good thing that you have, because you've not wasted your time. You've managed to do all these things. That's amazing. I think we can, after this masterclass of zero gravity, I think we can go back to per se just a bit to say so. Persei started in 2023, you said.
Mhm,
And so how was, and out of learning from the experience of two European projects,
mhm.
so how was it, how was that transition, or how was the birth of Persei Space?
That's a good question. So, Persei Space started in 2023 from these two European projects where I wasn't initially part of. But the major coordinator of these projects, who is Professor Gonzalo Sánchez Arriaga, wanted to step up into these projects in order to make the transitioning from a research oriented project to a commercialization company. And the EIC, the European Innovation Council, is very, very good at that because they are very good into transitioning and giving the tools, the ideas, and the mindset to researchers in order to take your idea, develop it, and put it into the market. And they really help you out with that. So when the time came, I think it was probably early 2023, of the decision of, well, how can we best commercialize this technology? Is it going to be one of the partners within this European project, the one that is going to take care of the commercialization? Are we going to sell this technology to somebody else? Then the decision was made that the best way to commercialize it was to create a purposely built startup as the step and the pathway to commercialize this technology. And this is how Perse was created. So they contacted me months before this happened because they needed someone to take the lead into funding the company, being the CEO, and the transitioning from the research oriented to the commercialization point of view. And this is how we created Persei Space.
That's amazing. That's amazing.
With
And
a
then,
lot of
and so,
problems, things to do at the same time as I was doing my PhD, and at the same time I was doing my second bachelor in physics. So a lot of stuff happening at the same time. So
so wait, you're doing a bachelor in physics
I'm doing a bachelor in physics in my free time.
after getting your PhD on water propulsion.
Yeah, I mean, I started in 2018 this bachelor's degree, but I'm taking it part time, and every time I have the time to delve into new physics and science because I'm in love with science, physics, and how nature is around us, then I take the chance to actually learn about new stuff that I can actually apply to be very good in technical stuff, which to me is very important because if you are managing a team, and this is probably that also happens to you, Jaime, I think you need to have enough technical competence so that the people that is behind you or the team that you are leading knows and respects your knowledge. If you are working on something that you have no idea about, then I think it's much more difficult to create trust and to build up enough confidence and the traction to make something happen. So I always try to make myself better in technical stuff in order to not forget about it.
Wow, but that's amazing. I mean, a bachelor in physics, it's no like, it's not like doing a mini course or
No, no, it's very difficult. I have to say that because the exams are, of course, presential, so you need to study on your own. Then there are things that, for example, as an engineer, I never thought of, even studying. Like, as the engineer, engineers and physics are very well related and merged together.
Mhm.
And when I was at CERN, at the European Organization for Nuclear Research, I could see this firsthand. Like the researchers making new experiments or thinking about new ideas, or the physicists, and then you have the engineers that make it happen. And you need a very natural flow between the two of them in order to have a smooth communication of what the scientist and the physicist wants and how the engineer can make it happen. And in my case, I wanted to have the two perspectives, the one of the engineer and the one of the physicist, so I could better understand how to make projects and how to put them in reality. And it's very interesting to learn about quantum physics, electromagnetism, thermodynamics, control systems, and so on and so forth. But it's, of course, very tedious as well for the mind.
Yeah, I can imagine. I can imagine, especially leading a company, because you're now also, and I was gonna, before before you mentioned this about the physics bachelor, I was gonna ask you. So, you you have your demo mission planned for 2026, right?
Mhm, correct.
How is that going? The preparation for the mission?
The preparation of the mission is going as planned so far. So we got a few days ago, for example, a small grant from the European Innovation Council, which is called EIC Booster, which is a small grant that is going to allow us to cover partially the cost of the mission. Also, as we are incubated by the European Space Agency and Fundación Madrid Master, then we are allowed to have and be in contact with a law firm in Spain in order to help us do the legal procedures about how to make a satellite under the Spanish flag ready in space. Because it's not like you can launch something and that's it. You need to ask for the right orbit. You need to ask not to people in Spain, but to people all around the world if the frequency of communications that you are using is something that is going to disturb people around. And this is a very tedious process in which you need to talk with the Spanish authorities, they need to understand the mission, they need to approve it. And at the same time, you need to develop the EQM, the engineering qualification model, do the testing, apply the lessons learned to the flight model, sign the launch service agreement with the launcher, a lot of stuff. But luckily, as this first demonstration mission is going to be part of the European Innovation Council project ETIPAC-F, which is the one of the two ones that Perse was built from. We have very, very good people in the team that are helping us and the project out in order to make it happen. Otherwise, for a startup, this would be very, very difficult. 2023, a startup put something in space just by themselves in 2 years is something not very realistic.
Exactly. It's very complicated because all the I would say administrative, but it's not just administrative, but so to sort of to group it somehow, all the admin work that you have to do to get the license to and get all the approvals to then launch something.
It's very, very difficult. Right now, like luckily, one of the things that we did in Perseid during 2024, 2025 is to sign an agreement for which we are the legal owners of the EQM and the FM, the engineering qualification model and the flight model. And as we are the legal owners, then we are allowed to actually fly this into space under the Spanish flag, which is something that not many people have done in the past. Like typically when you fly a satellite, it is Airbus under the French flag or another large integrator, the ones that is actually doing the IOD, the in-orbit demonstration. But for a Spanish company to be the leaders of an IOD is something remarkable. So if it goes well, for Spain, it's also a very good milestone to have achieved.
And especially in the area that you're working in, because it's not, let's say, it's not just another commercial mission, but it's something rather novel and that solves a pressing problem that
Exactly.
many countries are coming to accept and see more of as a problem.
Yeah, if the IOD goes well, Spain can be very grateful because they would be at one of the major forefronts of space safety and space debris stuff, which is the technology that we are making. So we are going to try to make them proud.
Let's see. Are there any other companies or any other countries building a similar or building something on this area about space debris like you are? Apart from the from the companies building a catcher, a satellite that.
So, for example, there are some initiatives on tethers system, but the initiatives that are being developed right now are initiatives that are not European. So people in Japan are working on the same, people in Iran are also doing the same, but in Europe we are let's say the startup or the company that has the major heritage of electrodynamic tether technology because we have incorporated it from 2019, and also we have the people in the team who are the major experts on electrodynamic tether around Europe, or at least the most renewed ones. So we have the competitive advantage of the years of development, the funding of the technology that the European Innovation Council has given to the ETIPAC and ETIPAC-F projects, and also the fact that we are going to have the in-orbit demonstration next year. So we are happy that we have this technological advantage and the time advantage too.
Okay, and just a question out of curiosity, for the in-orbit demonstration mission, you build it all yourself, or are you, let's say, approaching companies like the Orbit and so on to let's say support you on building the actual IOD vehicle?
So the ILD, the subsystem that we are going to put in orbit, which is 20 kilograms and 12U, is something that we are doing internally within the ETPAC-F project. So within the ETPAC-F project, we have Universidad Claustro Cero de Madrid, we have Universidad Dresden, TU Dresden, Universidad of Padua, we have Sener Aeroespacial as the company, and we have Rocket Factory Asburg as the client because, as I told you, the European Innovation Council wants you to change from research to a product and to a company as soon as possible. So we integrated a client into this technology in order to validate the business model as soon as possible. So these partners, apart from Persei, who is also part of ETPAC-F, are the ones in charge of building the stuff. So we don't rely at the moment into
Okay.
any other partner, at least for the subsystem of the deorbit device. When we talk about in-orbit servicing vehicles and to scale up the company from deorbit into propulsion and how to make the propulsion system for in-orbit service vehicles propellant-free, then the idea is that we are in charge of contacting and making partnerships with active risk removal partners, like for example Astroscale or the Orbit, in order to integrate this propulsion system into the spacecraft that they're building for these missions.
Okay. That's very interesting. Good to know. And what are your plans for Persei Space in the, let's say, medium to short to medium term in terms of, yeah, like funding, growing the team? Yeah.
Yeah, it's a good point. So what we want to do at the moment is basically to secure enough funding for the next years. And for that, what we are trying to do is to open an investment round. And we have two ideas. So we can have investors come to the company and lead the investment round, or they can co-invest with other investors. And the idea is that if you can co-invest with other investors, you reduce the risk of your investment because there are other people involved. And the ticket for this co-investment can be something relatively small, even I don't know, 10, 20,000 euros, not much, because it's a crowdfunding approach, right? And so the first thing is to close our first investment round, which is something that we're going to be working on. The second one is to continue applying and receiving national support in order to develop this technology in the sense of public funding or in the sense of projects that we can be involved with. And this is something we're working on very intensively and not only at national level but also at a European level. Like for example, the European Innovation Council has a project called the EIC Accelerator, which is a grant that is very important in order to grow the company. And as soon as we have all this funding secured, what we want to do is to hire a CTO for the company. So if you know someone or you think someone can be interested into being my right hand into bringing Persei to success, then we will be very happy to contact the people as soon as we have the fundings for that.
And how are you seeing the, let's say, the perception of, or of per se into the global European ecosystem? Do you see it sort of matches what Europe wants? I guess it does because of the problem that you're solving. But yeah, how are your conversations with other partners, with the EIC? If you speak to them, how is that going? The interaction with the rest of the European space ecosystem.
Yeah, that's a very good point. So the first thing that we did and we are doing is actually to get to know each other and to know that Persei Space is something that been there. We are having the IOD and to increase the outreach of what we are doing. And for example, we see a lot of traction with the European Space Agency on how these technologies can be adopted. So we had meetings with them. We were invited to the ESA Zero Degrees Week. We signed the Zero Degrees Charter, one of the first companies to do it back in 2024. So we are in the ecosystem of ESA Clean Space, and we want to help them into the transitioning from goals to actually quantitative and something that can help the industry, both service providers and clients. So this is something that we want to work with. Also, the European Innovation Council has really supported us into making this happen. And if it wouldn't be because of them, we wouldn't be here, because the two projects that were the base of Perse were two European Innovation Council projects. So we want to also help them to increase the outreach of what they are doing, because investing a lot of money, but a lot of money into space debris sustainability is a very big play, and to me is the smart one. And we want to see that this is something that is going to be successful in the future. And for that, it's very important that we recognize the importance of bringing all these funds into the sustainable technologies for the circular economy. So in terms of space agencies or European organizations, we're very well connected. And also what we're trying to do now is to also talk with potential clients, because we have the inaugural demonstration for next year about the prototype, but to change from a prototype to a product, you need the client's feedback. And the client's feedback is very important in order to know what they're actually looking for in terms of mass, autonomy, not autonomy, power requirements, size, etc.
Yes.
So for that, we are in contact with different potential customers in order to shape this collaboration to something that can actually make the integration more seamlessly in the future. We are, for example, incubated by Thales Alenia Space,
Oh,
starting from May 2025, so 2 months ago. So, and one of my colleagues is going to be in Torino, in Thales Alenia, working on the industrialization of this technology. And this is actually what you should do as a startup. Talk with clients, not to get in love with your idea, but what the client wants, which is something that sometimes can be difficult to do, and develop something that at the end is going to be useful for them. And, for that, communication is very important.
indeed, indeed. But I want to stay with one thing that you mentioned at first, because as you're very, I mean, most of you've done a lot of research, and part of a great part of your experience on of what you've achieved today is born out of the academia, no? And I see you want to give back to academia and to sort of support research projects, because out of research projects many good ideas like Persei Space can come out.
Yeah.
That's a very good point. How do you see, like, I guess you said it already, but how do you see the value of research and investment into academia, research projects and yeah, universities on the space industry in Europe?
Yeah, it's a tricky question, because investment in academia is something that first needs to be done, but needs to be done in the right way. For example, one of the things that happen in physics is that we want to come up with a theory of everything, right? A theory that
Yeah, yeah.
combines quantum physics with general relativity, with something, with everything all together, right? And everyone is focused on the string theory. The string theory has been the main framework for merging quantum physics with general relativity. And the truth is that string theory hasn't produced anything meaningful for the last 10 years, right? Like, there is a very beautiful background, very beautiful ideas, but there is no single evidence that it is true. And there are no enough proofs that what you are getting out from it is something that you cannot get using another theory.
Yeah.
So in academia, investing is very important, but also you need to be open to new ideas, not to put all your eggs in the same basket, but to diversify, to be able to open new research lines, and also be very open-minded about new ideas. And the things that happen in the space sector is that the space sector as a sector is very conservative. It's very difficult to make business in a space. It's very difficult to put things out of in a space. It costs a lot of money. Investors always pressure you to have results, etc., etc. To make new technologies is something that is risky, and typically the space sector doesn't want this to happen. But on the other hand, academia is the perfect incubator for these new ideas to take place, to be shaped, and to actually become something useful for a product. So I think in terms of academia, it's very important to first diversify, be able to search for new ideas, and also be able to discard ideas when it happens, which is something I will tell you later, but it's also very difficult. And to be able to set the standard in order to say, okay, this idea is good, then let's move it to the market, and let's build something out from it. Because science and academia is something that you don't know if it is going to turn out to be well or a good idea or a
Yeah.
bad idea. And it's much easier to say it is a good idea than it is a bad idea, right? For a
Mhm.
researcher or for someone that you are working in a university or that you have been given a 3 million euros grant, to say that something is a bad idea is very difficult. It's very difficult for you, for your mental strength, for the possibilities of you to get another grant as well. You know,
Mhm.
it's not
Mhm.
just up to
Of
you,
course.
but if you work on something and they give you a lot of money and they say it's a bad idea, then the amount of funding that you can receive afterwards can be impacted, you know. So it's very tricky, but you need to be very careful and you need to say more explicitly, in my opinion, when things are a bad idea. Because otherwise, people that are going to be working on your same idea 10 years after are going to see your research, what you did, and maybe are trying to do the same because you didn't say if this was a bad idea or a good idea. You said maybe you explored X way and that. So I think we need to be more clear and
Exactly.
honest on
Yeah.
that, in my opinion.
Companies tend not to have that problem because if something is a bad idea, the market will tell them eventually. Even like, let's say, a founder can sort of close his eyes to reality, but the market eventually will let him know that that's a
Exactly.
bad
You
idea.
cannot
But yeah.
you cannot lie the clients, right? But
Mhm.
in terms of academia, like things on paper always look very, very right, you know. And in my opinion, be able to say, okay, this is a bad idea and this is a good idea, then this is something that for me is very important. For example, the DCH dynamics, the lock of effect, to me is a
Mhm.
beautiful idea, a beautiful idea. And what we did was amazing in terms of having an attitude control system that doesn't require energy, that can be controlled, etc. But to me, it's not a good idea for satellites. And this is something I can say openly because I don't
Mhm.
want people to get embellished with new ideas and new stuff, you know. And in the case of Persei Space and electrodynamic tethers, I think they're a good idea, but we need to test them. We need to see how they work and how it turns out to be, and be very clear about what ideas are good and bad in order to push forward as a community and put more funding and more effort into the good ones and be able to also discard the other ones.
It's true because academia is, in a way, the best place to try out risky ideas because there's a lot of research that you have to do for to see if a difficult technology or something that has not been done before can be done, and the perfect place to do that is in academia. And once you validate that it can be done, you have to sort of take the step into tapping into the market to say, hey, is this something useful for the market, yes or no? So I think you're very right in what you've said. Okay, Jesus, I think it's time we close the call, but it's been a real pleasure talking with you. I don't know if there's anything else you would like to share with the audience.
Yeah, maybe if the audience is still there and if it is a young audience, I wanted to tell them that what I do also in my free time is I try to help people to escalate in their space career, achieve their professional goals, help in their decisions into, for example, do a master's abroad, do a PhD program, not to do a PhD program, how to get into every job that they want. You know, in my case, I develop a set of skills that I think are very unique in the sense that I can be able to be accepted into certain positions that not many people can. And this is something I can do. And for example, I have my website is Jesus Manuel Muñoz Tejeda.com. So you can contact me in the website, and there are paid services. And also, if you contact me in LinkedIn or in Instagram, my Instagram is Jesus Muñoz Tejeda. Then I post there my career journey, and I can also help you out for free. So if you need any quick advice or something, send me a message on Instagram, and I always happy to respond, saying some voice memo and help people out. Because sometimes having someone as me, if I were me 5 to 10 years ago, is something I would have appreciated a lot because it would have saved me so much time and a lot of problems in my head. So if you want to also escalate and do something similar as what I'm doing, be free to reach me out.
That's amazing. That's amazing. Thanks a lot for that. I think it's going to be me, the first person who will send you a message.
Of
So
course, you are completely welcome, Jaime.
it's been a real pleasure, Jesus. Hope for the best for Persei Space and for the next 1 to 2 years, because there will be a lot of news to share. So I guess we will speak soon, no? Before or
Yeah, we
right
will
after
speak.
your IOD, we could have another chat.
Perfect. Yeah, well, let's talk about the IOD, and many thanks, Jaime, for you, for your time, this amazing initiative that you are building, a part of your normal job, which I think is something really, really admiring. And we hope the audience also supports what you are doing, which I think is very important.
Thank you, Jesus.